Hi everyone, today we are going to continue our discussion on points, lines, and planes by discussing the intersection of points, lines, and planes. Before we get started, you will need your one subject notebook. You will need to print out the Unit 1 Day 2 video lesson cutouts for our interactive notebook, some highlighters, a glue stick or tape, and of course you will need scissors. Please pause the video to make sure that you have all of the materials that you need to get started for this lesson. All right, the first thing I want you to do is cut out these two sets of cutouts as you guys see right here. There will be no flaps or anything crazy we will do this time around. It will simply be just plain cutouts. I like to use colored paper. I think that it helps to make things clearer whenever we create the page. And there will be 2 pages for today's lesson. The first page will be discussion of intersections, as well as some language and statements that you will need to know. We will not have a midterm for this semester, but in future courses, we might have, or in the future, we might have other assessments. All right, here we go. So day 2 is called the intersection of points, lines, and planes. Our learning target for today is for you to be able to say, I can identify, and with language, I can name with words and explain in words why a figure represents the intersection between 2 geometric figures. The word intersection in geometry means the set of all points. And I'm going to put the letter S for points in parentheses because it might just be one point. But it is the set of all points shared, which means that they have them in common, shared by 2 or more geometric figures. What do they have in common? And that is the word of intersection. And we think of like intersection of roads or the intersection of states, the intersection of countries, the intersection of points. It's where they all share or they meet together. So the first thing I want you guys to do is find the cutout, leave a little bit of space, but I want you guys to find the cutout that has point M. And we are simply going to paste that into our notebook. Leave a little bit of space for you to do some writing just above, maybe 2 to 3 lines of space. And we're going to just simply glue this into our notebook. If you have tape, tape it in. That's fine too. All right, so the first thing that we have here is point M and line J. And what we're going to do is we're going to draw a line and a point. This is point M and line J. Notice that J is called line J, which means that we are not talking about, this is supposed to be the letter J. We're not talking about a point that's on the line. And where these 2 figures intersect is they intersect simply at one point. Point M is the intersection. Point M is considered the intersection. So what I need you guys to know is that a point and a line intersect simply at one point. So a point and a line will always intersect at one point. And the emphasis here is that they intersect simply at one point. So a point and a line intersect at a point. The next figure that we have is line J and line K, and we want to talk about the different ways that they could intersect. And there are two ways. You could have line J and line K intersect at one point. So two lines could intersect at one point, or, I'm going to put a big huge or, two lines could be one right on top of each other. Or this is line J, and then I could draw a line right on top of it and call it line K. So what that looks like, if I were to use colors, is I would have line J would be in green, and then line K would be right on top of it in blue. And so therefore they would intersect at every single point. Their intersection could be at one point or at one line. Every single point that is on that line. So those are the two different ways in which these two lines could intersect. In this case, if we were to call this point A, the intersection is at point A. So A is the intersection. Or right here, you would have two lines on top of each other. So those are the two ways in which you would have two lines that would intersect each other. The next one is a point and a plane. So how they can intersect is you could simply have a plane and a point within the plane. So here is point M inside of plane P. Now plane P is going to be in script, and it doesn't have a dot next to it. So therefore we would consider it to be the name of the plane. And so simply M is the intersection because it is inside of the plane. So M is considered the intersection. So how point M and plane P or any point intersects with the plane, is it a point and a plane intersect at one point? All right, cool. The key word here is the word inside. So that is something I want to emphasize, that we are talking about inside. That's where the intersection would be. All right, let's go ahead and get out our next cutout. Leave a little bit of space. And we are going to glue this inside. So now we are going to talk about line J and plane P. There are two ways in which a line and a plane can intersect. So what I'm going to do is I'm going to draw plane P, and I'm going to draw line J inside of plane P. And therefore, the intersection is line J. Every point that is on line J would be the intersection because J is inside of plane P. So line J is the intersection. Or there is another way that this could happen. You could have a plane P, once again, but line J only intersects at one point. They only share one point. We can call that point A. So it would we would say that point A is the intersection. So there are two ways in which a line and a plane can intersect each other. The first way is a line and a plane intersect at either a line, at one line, or one point. The next one that we have is a plane R, or plane P with plane R. And this is kind of tough to draw. So there are three different ways in which two planes can intersect. Here's the first way. They can intersect at a line. And so what I'm going to do is I'm going to draw two rectangles. And they are going to intersect each other. But when I go in between, I'm going to use a dashed line. So I'm going to draw my first rectangle. We'll call it P. And then I'm going to draw another rectangle. And as soon as I get to this inside, I'm going to use dashed lines. And then a line on the outside, coming down, going around. And I believe that this one is allowed to be solid this time, to show that it's on top. And we're going to call this plane R. And where these two planes intersect is they actually intersect at a line going through these two planes. And I know that it's kind of tough to tell, but you could have these two planes intersect at a line. And I'm going to call it line J, in which we would say that, I'll highlight it. We would say that line J is the intersection of these two planes. So two planes can intersect in the following ways. We can say two planes intersect at one line, or here's the next one. We could have two planes intersect at simply one point. So this will be plane P, this is plane R, and they simply intersect at one point, and we'll call that point A. And we would say here that the point A is the intersection. Or, so we could say that two planes intersect at one line or one point. Or, just like with lines, we had one line on top of the other line, you could have two planes, one on top of the other, where this could be considered plane P and plane R. Where you would have plane P be right here in yellow, and then you would have plane R be right on top of it. And so therefore they would intersect at every single point. And what this is, if I were to draw a little arrow, is this is two planes on top of each other. So they would intersect at every point. We would say that they would intersect at a line, a point, or a plane. Most of the time in this class, you will see where two planes intersect is typically at one line. That's where we typically see. Most of the examples will be like that, but I want you to always think, is it possible that something else could exist And in this case, it is true where there are many possibilities. The final intersection is simply a point and a point. So point M intersecting with point E means that they simply share the same exact point. So I'm going to make this a green point and a yellow point on top of each other. So if you're talking about the intersection between 2 points, it simply means that the 2 points are the same. So there are some sentences that I need you to be aware of because you might see them on assessments. And so there's 4 statements, and I want to make sure that I talk to you guys about them, so I need to flip the page. Here is, I want you guys to study and understand these statements. So study and understand these statements. Here is statement number 1. If 2 distinct, and the word distinct, we'll highlight that. If 2 distinct lines intersect, then the intersection is a point. Distinct means different lines. If 2 different lines intersect, then the intersection is a point. And what that looks like is 2 separate lines going in their own directions intersect at a point. And so once again, so this is my quick example, and I want you guys to know that the word distinct, whenever you see that word, it means 2 different lines. Distinct lines means different lines, 2 different lines. That is distinct. Keyword here being different. They go in their own directions. The statement number 2 is if 2 distinct planes intersect, then the intersection is a line. So distinct, once again, means different. So if 2 distinct planes intersect, then the intersection is a line. So what that looks like is, once again, if you have a rectangle, if you were to draw a rectangle and then draw a skinnier rectangle, kind of going through it, where these 2 planes intersect is at a line that is going along the diagonal. All right, the next one, statement number 3. There are 5 statements, by the way. Statement number 3 says, through any 2 distinct points there is exactly 1 line. So for example, if you have two distinct points, that means that we are talking about two different points. We'll call those point A and we'll call this point B. There is only one line that can go through those 2 points. And that is for any 2 points. Statement number 4. Through 3 non-collinear points, there is exactly one plane. Okay, let's talk about that one. So through 3 non-collinear points. Okay, non-collinear. So we're talking about 3 points. Non-collinear means that they are not on the same line. So 3 non-collinear points, not on the same line. So if we were to draw this as an example, what you're going to draw are 3 points, like point C, point D, point E. There is exactly one plane that can go through all of 3 of those points. There's only one way to draw that, and that is through a plane. And we would name that plane CDE. And this is what it would look like. Our last statement just giving it a little bit of color. Our last statement is if 2 points are in a plane, then the line containing the points is in the plane as well. So what that looks like, or what that means, is if we have 2 points that are in a plane. So let's go ahead and draw that. I'm going to have 2 points. We'll call them F and G. These 2 points are located inside of a plane. Then the line containing these 2 points, so let's draw a line inside of this plane. The line containing, so that means that it's the points are on the line. The line containing the points must be in the plane as well. So line FG has to be, no matter what, line FG has to be inside of the plane. And that is the end of today's lesson. So today's lesson was all about intersection, and we talked about intersection of points, lines, and planes a little bit further. And a lot of the figures that you're going to see in this class will have a lot of intersecting parts to it, geometric figures. So I want you to feel comfortable with the idea of working with intersection. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.